This is all just running on a VM on my local laptop here. So we've got effectively a version of the database. It's all just running straight out of SQL Plus and SQL CL, so no smoke and mirrors. These are just the scripts that I've been building over the last year that show various features in Oracle database. Because I am using a fresh cut of the code, standard safe harbor, etc. This is literally the list of demos. So I wrote myself a little menu system. It's all just running out of SQL Plus, and we can fly through them. I'll do this one first because this is one of those strange ones where one of the things that I've always been terrible at is writing the word from. I do form dual, I do FMO dual. It really annoys me because, especially as my eyes get worse, I, keep messing it up. In 23 AI, from dual is now an optional term. So anything where you did select something from dual, you can just do select one, select six, next file, etc. So the reason I do this one first is I did this at Kscope last year. I think this is such a trivial thing. Literally, people got up and they applauded. They thought this was the greatest thing that had ever happened. And I was a bit bemused. But then I went to India and I did the same do in India because I thought, they will love this. And someone put his hand up and he said, why does Oracle waste their time with such trivial things? So you either love this or you hate it. I'm not sure, but it generally elicits in a response. PL SQL function. Now, one thing to be aware of is what it means is if you have any code that currently has from dual, you'll need to remove that before upgrading. I'm just kidding. Can you imagine? It works fine. So don't worry about that. All your existing code just works fine. It's just to get some adrenaline into the room. So that's number one. Number two, it only took us 40 years, but we finally got ourselves a Boolean data type. I know that we've been doing this. If I got a person table and we got a married column, which indicates yes or no, we've all been doing Y or N or number one or varchar21, etc. Thank God, finally, we can now have a Boolean data type in the database. Because we were a little bit slow on the game, I accept that. What we've done is we can obviously insert true or false, as you'd expect. That's a Boolean. But obviously, your apps probably aren't doing that. Your apps currently are inserting Y, N, 1, 0, etc. We will accept all these things. On, off, 1, any positive number is true, 0 is false, Y, yes, no, etc. Right? And we will simply convert them to true or false. Okay, so that's very, very cool. Be aware that obviously, if you are querying it back, then it would come back as true and false. So your application would need to understand that. If you're using an old Oracle client version, we bring them back as ones and zeros. So we were very focused on understanding that we were a bit late to the game. So we actually said we'd do our best to send data back as it used to be. But if you're on an updated client, you'll get true and false back. Old client, you get ones and zeros back. Even though I said yes and no, it's not language independent. It is just literally the English no. But it's a full implementation of the data type. So, you can do where married, not where married equals true. It's just where married because that's already a Boolean expression. Same thing with a case expression, etc. Things like reg expression light. There are various where clause facilities that used to return a true or false. Things like regular expression like, the exist clause, etc. They could only be used in where because they were Boolean. Now they can be used literally as part of the select because we can return a Boolean. Things like this. We used to do select where exists, select one from them. I can just do it like this now. Select exists can now be run because it returns true or false. You can put indexes on them. You can put constraints on them. It's not like we just sort of bolted it on. It's a complete implementation of the data type. Similarly, we've all known there's been Boolean for a long time in PL SQL, and you'll be pleased to know there's that nice interchange between them. I can get a Boolean from the database into a Boolean in PL SQL. That works fine. I can insert them, etc. It does raise this interesting concern, though. In any version of Oracle at the moment, if you do b equals 1, this gives you an error. And it's meant to, because that's obviously invalid. But I've just said, with 23 AI, when you're doing Booleans in the database, we'll let you do 1, 0, Y, N, etc. because we're trying to help with backward compatibility. But that obviously flies in the face of what PL SQL used to do because it already had a Boolean with stricter rules. So you have this decision to make. And by default, we do this because we want to preserve backward compatibility. This used to break in PL SQL in 19C and below, so we want it to break in 23 AI so nothing changes when you upgrade. If you're happy to have that more flexible use, you can change this parameter at system or session level, and now b equals 1 will be fine because it'll be converted to true. So be aware of that. We have the choice now, but by default, we're preserving backward compatibility because we hate breaking your applications when you upgrade, etc. Okay, 3, group by. Group by obviously is nothing profound. We've had group by forever. You have some columns, you group by those columns, the job is done. But of course, in real world applications, it's never that simple. Often the list of columns we're selecting is this huge string of complexity. And one thing I've always hated is you had to cut and paste it. The whole thing again for the group by, and you had to remove the alias because otherwise you get an error. 23AI, you can now group by the alias, group by bonus. You can have the having in the alias as well. If I do this, for example, group by one, remember, if I'm doing group by alias, that's like order by alias. I should be able to do group by one, just like order by one, but I can't. And the reason it doesn't like me do that is because by default, once again, backward compatibility. Group by one might mean something to you nowadays, group by the constant one. So we didn't want to change that behavior. If you're happy to allow group by one, just like order by one, you can do this parameter as well. And now you can group by one as well. So that's your choice. Okay, if exists. If I drop a table that doesn't exist, I get an error, as you'd expect. One thing I can do now in 23AI is drop table if exists. If the table is there, we drop it. If the table is not there, we still say the table was dropped. Why do we do this? Why do we use that same syntax every time? Because if you were running a script repeatedly, saying continuous integration, the most common thing we do is we compare the logs to see if anything happened. So what we want to do is be able to rerun a script over and over, and every time the log should look the same. So you've got drop table if exists, it'll still say table dropped. So be aware of that. It doesn't say table was not there or warning table was not dropped. It simply says table was dropped every single time to give that consistency of experience. Similarly, in reverse, if I create a table and try create it again, I get an error. Now I can do create table if not exists. Same thing. Now, be aware, it's simply an existence check. If I do create table if not exists X, and then create table if not exists X and Y, the database doesn't go, oh, what you really meant was you'd like to add a Y column to the table. It doesn't. It literally is, you created the table. Does it exist? Yes, do nothing. If it doesn't exist, go ahead and create it. So in this case, we still just have the one column here. If you see my arm dropping down here, then my dog has come to visit and is bugging me. So I'm trying to keep him from interrupting the call. Another cool thing, continuous integration, what do? You drop a table, you create a table, you populate it with sample data, you run your unit test. So drop the table, create the table. How do I insert data? I write an insert statement. I write another one. I write another one. I write another one. That's a pain. In 23AI, the values function has been extended so it actually can have multiple rows. So one insert as many rows. I think the limit's 64,000, but yeah, obviously that's getting a bit extreme anyway. Single insert, lots of rows, nice and simple. Also, values is no longer bound to an insert statement. Values is now a standalone function. So for example, if I want to synthesize some data but not put it in a table, this is what I currently have to do. If I want to synthesize 5 rows, I do select from dual 5 times. Obviously now I can remove the from dual. That's cool, but it's still a bit wordy, isn't it? So I can do this now. Select star from the values function. Values is now a standalone construction function for constructing rows. If I do it this way, select star from values, I need to tell the database what my table was called and what the columns were, so they need to come at the end. If that looks a bit weird, you can flip it around to use a with statement. I can say with emp list, table name, column name as, once again, just a values constructor. So values is now separate from the insert statement. Number 5, returning. Returning's been around for a long time. I've got 5 rows in my employee table. I set a variable here, could be in SQL+, could be in my application code, doesn't matter, and I can do update, set returning ename into some value. So I've always been able to do this. Is existing since Oracle 7, I think. But it's a bit weird in the sense that I'm always returning the result as opposed to the predecessor. So for example, I've set my employee name to Connor, and I'm returning the employee name. Well, I'm pretty sure I know what the employee name is going to be because I just set it. What I really wanted to know was what it was before. And I challenge anyone, what was employee 3 before I ran this demo? You saw it, but of course we don't remember. We want to know what it was before, not after. And so, that's fine. But what we can do now is have returning old and returning new. They are optional. So if you just return one value, by default it's new. If you can return just the old, you can return just the new. If you leave old and new off, you get the new for backward compatibility. But you can see we actually went from Mary to Connor. That's what returning does now. You can get access to both the previous value of the row and the post value of the row. error messages have been improved. Let me give some evidence of that. If I connect to any old version of the database, I've connected to version 21 here. I did department number, job, count star, group by department number. That's invalid. So as a developer, I've got an error saying my group by was not valid. And what useful information did we give you? We said, yes, your invalid group by is not a valid group by. There's nothing that helps me solve the problem. Let's now connect to version 23, exact same demo. This is the error message you now get. It says job must appear in the group by. It needed to be here, or it needed to have an aggregation function around it. Like if I did max job, whatever, then that would have been fine as well. But now you can see these error messages have been tweaked or improved because it's been so long since we had a look at them. This was actually a separate project in Oracle, not related to 23. 23 is just the first version you get to see them. We literally got all the error messages lined up. And we said, okay, let's see which ones I think we can improve. Let me give you another example. I drop a table if it already exists, create a table with a primary key. So I insert the value as 1, and obviously if I insert the value 1 again, I get an error. I used to get duplicate constraint error. Now I get this. You can just violate it on scott.t. It tells me what the column was. It tells me that a value of column X with 1 already exists. We used to just get that. Now we get all of this. And you'll see this throughout, right? We've been through many of the error messages. Anywhere where we think these could do with a bit of a spruce up, then we should improve them. Okay, the one-line developer. Oops. As I said, part of the Oracle mission was to make things easier. And if you're brand new to Oracle, it can be a bit weird. Like I download the Oracle database. We got a free version you can download. You do some Googling, you find out how to create a user, and then you say, okay, let's do something. And you can't even connect. It's frustrating. Like what is going on? And of course, that's because by default, we give everyone absolutely no privileges to anything, and connecting is a privilege. So poor old Jane Doe does some Googling and says, oh, yep, okay, I need to do grant create session. Fantastic. Finally, I can connect. Cool, let's create some tables. You can't do that either. We as DBAs know what this is for and what the reason was, but for someone who's a novice or brand new, this is a barrier to entry. They're going, screw this, I'm going to go use some other database. So in 23R, we have this new role called the DV developer role. When you grant that, and you can connect, what do you get? You get pretty much everything you would need to be a developer on Oracle database. And the good thing is, it's a single role that obviously as the database evolves, this role will evolve over time as well. Everything you need to pretty much get up and going on the database is there for you just with that one grant. Now, if you're a DBA on the call, you're going, well, hold on a second. Every script I've got floating around looks like this because this is what we've done for the last 30 years, grant, resource, and connect. What we've done is we've spruced up the resource role as well to some degree. So now your existing scripts will give an experience very similar to what the new DB developer role will look like as well. But ideally, you just go DB developer role. This is the one that DBAs will love. Let's say that developers are on our system. It's very rare that developers build things in their own schema. What we generally do in development databases is give them access to a central schema. In this case, for example, the HR schema. So I've got 7 tables in the HR schema, and we just saw we have a developer named Jane Doe who's going to be using our application. So what do? We grant the first table to Jane. We grant the second table to Jane, the third table, the fourth table, etc. We might build a role to do the grant to that. Still the same problem. If you're running, say, Oracle eBusiness Suite, that script is 25,000 lines long. And every time you apply a patch or do something to your database that might change the number of tables, you need to go update that script. A lot of us have written, scripts that loop through all the objects to do grants. All these things are just a pain. What we've done now is have a schema level privilege. So in this case, you can select anything, but only in the HR schema. So we always used to have individual objects or everything, select any. Now we have this nice middle ground, which is anything in a particular schema. And the good thing is it's obviously now future-proof. If I create a brand new table in the HR schema and connect as Jane, she can see it straight away. I didn't have to do any particular grant on that object because it's now at the schema level. Very cool. Multiple direct loads. If you have a data warehouse, what do we get taught? We say if you want to do a direct load, in this case, I'm going to create a table called emp2, which is empty. It's got 1 = 0. It's a totally empty table. I want to populate it as fast as I can in a data warehouse. So what do? I do insert append. Direct load insert, bypasses logging if I need to. Very, very efficient way of loading millions and millions of rows. And once I've done that, the first thing I probably want to do is validate that this worked. And guess what you cannot do when you use insert append? You can't validate it. You cannot do anything after a direct load insert except commit or rollback, both of which are crossing your fingers. Rollback seems drastic because I just wasted all that work. Commit seems very drastic as well because I have no ability to validate what I've done until I actually go commit the data. That's very frustrating, and obviously some people don't use append for that reason. So that's what happens on 21 and below. In version 23, create the same empty table. I can do insert append. Even though this transaction hasn't committed, I can query the data. I can do more insert appends. I can do multiple direct modes as well and still query the data and then commit at the end. So all those restrictions in terms of being able to interrogate the data after direct load have been removed. Be aware, insert append still does lock the table. That hasn't changed. Okay, JSON duality. So this is what a JSON duality view looks like. I'm going to do a very simple one to start with. I've got my employee table here. I want to expose some columns from my employee table as JSON. At which point you're going, wow, that's hardly a big deal. I've always been able to create views that expose data in certain ways. But I can adjust that to look something like this. This is the cool part. It's bi-directional. This view is updatable. So if I describe that JSON duality view, it has a single column called data because we're exposing this information purely as JSON. If I query it, that's for a particular employee, that's what I get. Now, this is using SQL, but this could be, for example, a REST call. It could be something coming from a Mongo API. We support the Mongo API accessing these things. So a developer might be blissfully unaware this is even closely related to a relational database, no pun intended. They simply do a get on a REST call and out comes some JSON. They go, great, it's a document database. So if I update the relational data, I've changed the salary to add 99. It's immediately reflected in the JSON. I added 99 to this person's salary, which I think was 820. Immediately reflected in the JSON. But it's bidirectional. If I insert a JSON document, I'm using SQL here, but it could be a put request or a REST call. It could be a Mongo API store request. It's immediately reflected in the relational data as well. It's bi-directional. No one will ever know that the data is relational if they like their data as JSON, and none of your relational developers will ever know that you're giving the data away as JSON format. You have this wonderful synergy between the two needs. Let me make it a little bit more complicated because yes, a table that maps rows to JSON is trivial. Let's do something a little bit more extreme. I've got customers, orders, and order items in your conventional parent, child, grandchild data model. So here's my customer table with some rows in it. Here's my orders table with some orders in it. Here's my order items tables with some order items in there as well. I'm going to create a single JSON duality view. It exposes all of that as a single JSON document. So I've got the orders, the customer info, and the order items. Notice I've flipped it here. This thing is driven by orders, not by customers, even though customers sits at the top of the relational model. Then underneath the orders, I've got the customer information, and then I've got the order items presented as an array. But this is the cool thing. I can flip it as to how my JSON developers need it, as opposed to how it's stored in the database. So if I query it, we need a lot now. So this is, here's order number 1, and here's order number 2. I've spelled my surname incorrectly. That's a bit sad. But you can see I'm now getting this relational data back as if it was JSON documents. If I insert some relational data, so I've got my transactional system, for example, or an Apex app inserting a row into an order items table for a given existing order, it immediately appears in the JSON for that order. Once again, bidirectional. If I do a change to the JSON, in this case, I've said go dig into the JSON, change and fix up my surname for a particular ID. It is immediately reflected in the JSON, but also immediately reflected in the database as well. Bidirectional, seamless integration between the two. Very, very cool. That's JSON duality views. Okay, let's jump around a little bit. How are we going for time? Let's do, speaking of JSON, if JSON's coming in from external feeds, it's now incredibly easy to load. So I've got a directory here on my database server where my JSON is living, and this is literally all I need to do now. I simply say, I've got from this directory, JSON docs, I've got a data file called data.json. So this is a JSON file with lots of data in it. And literally, this is it. This is all you have to do. It's a big data format with the following access parameters. And there we go. It's done. I've now loaded a whole stack of JSON data into my MBA table. So loading JSON is trivial. What else we got? Let's look at the SQL firewall. There's plenty of firewall products out there already in the market, but they all work in the same way. They sit either on your app server or somewhere on your network, and they interrupt traffic as it flows toward your database, and they do some introspection. That's all well and good, except that means you have to be incredibly careful about how your network is laid out, because all it needs is someone to find a path to your database that doesn't go through the applications, the network path that contains your firewall product, and they bypassed it. So for that reason, we said, why don't we put a firewall inside the database? Because then it can never be bypassed. So if you connect as a DBA, you'll first if you try to turn the firewall on, even that is a privilege. So even DBAs just out of the box don't get the ability, because obviously a firewall is a pretty full-on thing. It's a particular role, a firewall admin. Once I've done that, I can turn the firewall on. Now the question is, if I got an application that runs 5,000 different select statements, how do I tell the firewall that that's what they are? Well, it's pretty easy. You create what's called a captcha. A captcha simply says, in this particular username, every SQL that comes via this connection will now be captured while this captcha is running. I run my application. This is my application here. It's very basic. I connect to Scott. It runs this query. It runs this query. So name from emp, start from department, and a group by on the department. My application is so simple, it only ever runs those 3 queries. I connect as DBA again and turn off the captcha. But we've caught every single SQL that this application runs. I can actually have a look at them. You can actually see there's actually a few more than we actually ran. These are the ones I ran, and the group by as well somewhere, which is, here we go, there's the group by. What are these other ones? Well, they are scripts that get run when I run login.sql and SQL+. So when you connect to the database of SQL+, we often run a few queries. It captured those as well. One thing that's worth noticing, notice it replaced any literals with bind variables. So this is good in the sense that it's not actually a text match on the SQLs you ran. It's similar to the cursor signature that we have in SQL Plan Management. So it'll understand the concept of bind variables. It'll understand the concept of differing in case and white space, etc. It'll manage all that for us. Once I do this, I can actually see what the firewall captured. And there's all sorts of cool stuff. It shows me what IP addresses those SQL statements came from, what programs they came from, what operating system users they came from, and of course, all the SQLs that were caught. You can go modify all those things, change what app servers are allowed, change what users are allowed, change the operating. You can make all these rules. These are just your starting point for what's allowed. I'm doing nothing because I'm just doing a quick demo here. So what I do is I say, from now on, I'm going to enable that list of things I'm allowed. What users, what IP addresses, what SQL statements, etc. when you come in through Scott, and I've chosen to block it as true, which means if you give me something that's not in that list, you can't run it. You can also choose just to report it or capture it, so you can actually get a log of things that were actually blocked, but we're still allowed to proceed. So I connect to Scott. I can run that query because I ran it before. I can run this query because I ran it before. If I run a brand new query, it's not allowed to be run. SQL firewall violation. It is caught directly inside the database. You cannot bypass this in any way. Maximum columns. If I connect to Oracle Database 23 or below, out of the box, you can have up to 1,000 columns. So I've got a little routine here which creates a table and then goes and adds another 1,000 columns. I didn't want to type that as a script. So I created the table, and as you can see, I've got 1,000 columns in this table. When I do a describe, I try add one more column, and the maximum is 1,000. So out of the box, 23 AI is the same as all versions prior. You can have up to 1,000 columns. But you can change it. Max columns is set to standard. If you change it to extended and bounce your database, now I can connect to 23. This time I'm going up to 3,000 columns. I can actually go to 4,096 is the limit. But you can see my table now has 3,000 columns. Now, any data architects on the call are probably going, oh my God, don't ever turn this on. No table should have about 3,000 columns, etc., etc. I understand that it's obviously generally not considered good modeling. The reason we have this is not just from a purist point of view in terms of modeling. A lot of machine learning models, the way they work is they take rows of data and they transpose it to columns before running the modeling facilities. And that's where this requirement was driven. We had some machine learning models that typically use 1,024, 2,048, 3,092, etc. of columns because it's rows being transposed. And so we need to be able to accommodate that to run these models, hence the requirement. SQL analysis, which is, let's create a table called T1. It's just a copy of DBA objects. Let's create a table called TB as a T2 as a copy of DBA objects as well. And let's do an explain plan. Now, hopefully anyone on the call can see there's something dramatically wrong with that query. I'm joining two tables. There's no join condition. But one of the cool things in 23AI, SQL analysis, says that. You do an explain plan, it says, by the way, your query has a Cartesian product. That might be expensive. Consider adding join conditions. It's trying to protect us from ourselves as developers. It's unlikely a developer did this deliberately, they just forgot. So this, if we use, as long as you got explain plan turned on, we're trying to catch it before it goes into the next environment. Similarly, I put an index on the created column, and I do that classic time-old error of using trunc to remove the time component. So this query is valid in terms of functionality, but trunc obviously defeats the purpose of having this index. Explain plan tells me, you're doing table access full, the following columns have predicates which preclude their use as keys in an index range scan. Consider rewriting the predicate. So it's pretty cool. Similarly, if I do a union between T1 and T2, it says, has a union which might be expensive. We can't definitively say that this should be a union all, but at least we can give the developer a clue that, look, if duplicates are allowed or the two results are definitely mutually exclusive, then union all is going to be more efficient. So these just come out of the box. As long as you're using explain plan, it'll give you some notes now to help tell you that you can solve problems before they become problems. What else we got? If you're calling services, this will be the reason you upgrade to 23AI. If I go to any version of the database before 23AI and you try talk to the outside world, even if you do things like you set the network ACLs and all that kind of stuff, if you try talk with UT or HTTP, it says certificate validation failure. And the way you have to solve this is a pain. Similarly, if you're using Apex Web Service, same problems. The way you solve this is a royal pain because you need to get the SSL certificates from this site. So what you do is you fire it up in Chrome, and then you have to go to the little padlock and you right click and you choose export, and it asks you which certificate you want to export. It has to be the root level one. You then export that to a file. You got to make sure you choose the right base64 format, otherwise it doesn't work. Then you got to copy that over to the database server. Now you got this external file on the database server. It needs to be backed up. It needs to be make sure it's restored. If you're on a rack system, it has to be on all the nodes. It's just a pain managing these files just so you can talk to the outside world. And of course, people say, well, hold on a second. If I'd fired up Firefox on the database server, it works fine. So how does that work? And that's because at the operating system level on database servers or any server, you've got a whole stack of predefined certificates that are loaded as part of the OS. In 23AI, now we can take advantage of that. So notice here, I've simply made no reference to the wallet at all, and it went and picked up oracle.com. Similarly with Apex Web Service, same thing. It will simply use the operating system level certificates provided. If you have a custom customer site that uses their own certificates, you'll still need to go get them and bring them into the wallet. But you could also put them on the OS wallet, OS level certificates if you wanted to. But out of the box, the vast majority of all web services you need to now consume will now be just available without worrying about wallets and all that garbage because it now just uses the OS. That is absolutely super cool. What else we got? Let's do reservable. This one will blow your mind. Okay, this is related to what we call the lock-free transactions. I'm going to start with a real simple demo. I've got a table here called T. It's got a primary key and a column called column. Just to show there's nothing magic going on here, I'm not doing anything mischievous. This is the username. I'm connected on this as this user on this database. And the value in here is select star from T. There's one value, primary key of 1, column equals 10. I'm going to update that row and not commit it. So I've changed that row. I've added 1 to the value of column for the primary key equals 1. Let's fire up another session. So just to prove I'm on the same database here. So same table called T, same schema, same global name. What's going to happen when I try update this same row, which this one currently has locked? It will just sit there and wait, right? It doesn't. Like this like goes against everything we've ever learned about database locking. And of course, the question is how? Well, let's commit this change over here. So this guy also wanted to go add 1 to the value of column. So if I go back to here, it says the value went from 10 to 11. Well, that's what I did. So you might be thinking, yes, I allowed the two things to update the same row, but I've now got a lost update. That's no good. But if I commit this session, it went to 12. So even though we had these two people locking the same row at the same time, we didn't actually lose the update. We actually managed all that for us. Solving this, the question is why? What is going on? Well, it's this thing called reservable lock rows, right? And as I said, it was originally designed for things like microservices. But I'm showing a much more real-life example of why I think this is going to be an absolute super cool facility. Let's have a bit more of a realistic scenario here. I've got a customer table which has orders. So I'm going to create my customer table. There's two customers in my database. One's called Connor, that's me, and one's called Susie. Customer 1 is Connor, customer 2 is Susie. And we have some orders that sits underneath the customers table. So this might be my application. An application might be to create an order, I insert one into the orders table and update the total orders, being total orders plus 1. So when I come in as Connor customer 1, I bought something and the number of orders went up by 1. I bought another order as well, number of customers goes up by 1. If I look at it, yep, customer 1 has ordered 2 orders. My application is working just fine. So in another session, Susie logs on. So she's customer 2, right? She can also order things as well. And that works fine, right? We didn't have any problems talking to each other because we're accessing different rows. So in this case, Susie can't see that I've got 2 orders so far because I haven't committed, but she can see that she's got 1 order. If I commit that, go back to session 1, and I commit, now everyone's in a common state of point. I've made 2 orders, Susie made 1 order. My application is running just fine. Let's now go to version 2 of my application. I want to start storing information about the products as well. So I've gone from customer orders to customer orders and products to orders. So I need a products table. These are the things I'm allowed to order now: phones, laptops, and TVs. And I'm going to add it to my orders table, add some quantity. So I'm bringing my application up to version 2. I'm also going to store, in the same way I stored total number of orders for customers, I'm going to store the total number of products sold for each product. At the moment, all my products I have sold a 0. I'm going to clear out my existing data. So no more orders, no more customers, etc. This is version 2 of my application. It's no longer just insert an order and a customer. It's insert an order, update the customer, update the products. I, as customer 1, bought 5 phones. So the number of orders for me has gone up by 1. The number of products for phones has gone up by 5. That works fine. I've also, another order here, bought 3 televisions for customer 1. So for customer 1, orders have gone up by 1, and the number of televisions has gone up by 3. So what have I got? I've got 2 orders here for customer 1, and 5 phones and 3 televisions. It's all working fine so far. This is Susie, other customer logging on. So Susie logs on, customer 2, I've ordered 10 laptops. My number of orders goes up by 1, number of products for laptops goes up by 10. It's all working fine. Then Susie wants to buy some TVs. TV's gone up by 10 for customer 2, number of orders gone up by 1, number of TVs gone up by 3, and we are stuck. Why are we stuck? Because we are both competing for the products row for TVs. I bought some TVs, Susie's trying to buy some TVs, and we're both trying to update that summary row, and we're stuck. This is the fundamental problem when we roll up detailed data to a summary. It's really common everywhere in transactional systems, and it's really hard to solve because you don't really want to block Susie here from being able to buy a television just because I am. So what we've done in the past is we've done all sorts of things like materialized views, we've done deferrable constraints. It's got very, very fiddly. This is where these reservable columns comes in very cool. I'll commit these so we can see that we actually finally released everything. This is the change that comes in 23 AI. I can take columns that are going to be just done with deltas, like these number of total sold products, and make it what we call reservable. Reservable means it creates the impression that multiple people can lock the same row at the same time. Here's my laptop solve. So 10 laptops sold, and I'm going to create a new order now with 4 laptops for customer 1. and I'm going to update that product row for laptops. I go over to Susie. She's also going to update the laptops row, which used to block, and now it just works. That's the beauty of reservable transactions. Both these people have been given the impression that they've successfully locked the laptops row on the products table, but they haven't. I went up by 4 laptops. Susie went up by 4 laptops. So she commits, she sees 14 laptops. I commit, I see 18 laptops. So we didn't lose the update either. So what is going on? Like, how do we do this? Well, if I go look in my data dictionary, you can see there's this new table that's been created called a sys reservation journal. We are doing natively in the kernel what you had to do manually in the past. If I wanted to allow this, what I would do is I wouldn't actually update the products row. I would, for example, store the changes into a queue, and then when someone commits, have some process that goes and reads the queue to go backfit these changes. As I said, a lot of complexity. We do it for you. This journal table has these metadata in there, and it has the operations you're doing. When I do create a new order, what happens is I didn't actually lock this row. What I did was I stuck a row into the journal table. It says, yes, you've done an update, you're doing a delta, an addition, you're adding 8 more to the record for the phone. We've stored this information in a pending table, and when you commit, we go and roll the changes through this table, backput them to the product table in sequence order. Okay, what else we got? Let's do this one. Virtual columns. Most people are familiar with virtual columns, the ability to have a column which is based on some calculation of a real column. If I insert the value 10 into X, then obviously the value of Y is 11. It is calculated on the fly. We never stored this row. So as I insert this row, when I do a select star from T, I calculate the 10 to be 11. We can all do the same thing with PL/SQL functions. I'm only using a PL/SQL function here because I want to create a scenario that it's going to be required shortly. So here's the equivalent virtual column as a PL/SQL function. It's the same thing. Take an input, return it +1. Here's my same scenario now, but this time it's calling a PL/SQL function just to show you can also do this. I insert 10 rows in there, and when I query it, they come out +1. I have called this PL/SQL function 10 times, once for each row. And that's how virtual columns work. You can do this today. You've been able to do it since Oracle 11. But what if that virtual column expression is expensive? And this is why I'm using PL/SQL here, because I can fake it. I've said it now costs me half a second to run this function. Now, normally it wouldn't be a sleep, nor be some sort of complicated expression. It might be calling a web service, for example. Now, notice the cost of querying is enormously expensive. I did array size one so we could see them as they come, but all of a sudden, because this function gets evaluated at query time, it's expensive to show this data. If I drop the table in 23 AI, we now have the concept of a materialized virtual column, which means you pay the cost at row creation time, not at row query time. And in a lot of scenarios, we insert a row once and query it millions of times. So this makes a lot of sense. So you can see inserting a value of 1, it took half a second because I had to run this function to actually materialize the value. If I insert 7 values here, it takes 3.5 seconds. A function execution for each one. The inserts become expensive because this is an expensive function. But the queries are instantaneous. It's a balancing act. You can get to choose. Similarly, if I do an update, half a second doing an update because I changed a value, which means I had to rerun the execution, right? But query is instantaneous. You get to choose where you want to pay that price. You can also make this column where it says once you've materialized it once, it is no longer allowed to be changed, which means any kind of subsequent update is blocked. So for example, I insert the row, it's into this new table, that's all fine. I query it, it's instantaneous because I've paid that price already. However, if I try to do an update to set x equals x plus 1, that means x equals 6 is going to x equals 7, which means the value of y would change, and it says you cannot update that value. If I simply change my function, in this case to return the same value, then I can actually still run an update, right? There's no problems with running an update, just that if the value would have changed, then you'll be blocked, but you have that choice. So materialized virtual columns are pretty cool. Let's do vector. God, got to talk about vectors, don't I? Silly me. Okay, let's talk about vectors. So just to show we can create vectors nice and easily, as you'd imagine, we just simply give an array of numbers and that converts it to a vector. There's a couple of other vectors. You can see by default, they're floating point because in the machine learning world, floating point numbers are what we have with vectors. By default, that's nice and simple. Vector actually takes 3 arguments, the vector string itself, the number of dimensions, and what the data type is of those dimensions. Typically, vectors in machine learning models are either 1,000 in size or even higher. So this is just very simple examples. So there's an example of 8 dimensions. 8 dimensions. Here's a very poorly drawn diagram of a 2-dimensional 2 vectors, vector 1, 1 and vector 3, 1. You can see the distance between them is 2, and as you'd expect, that's what comes back. Between 1, 1 and 3, 1, the distance in Euclidean terms, which is just the actual Pythagorean distance, is 2. That's a floating point result, so I can convert it to a number to get a nice simple distance. Similarly, if I do your sort of high school, 1 and 1, that distance there should be the square root of 2, which it is. So it's just some real simple vector stuff to show that the vectors actually work. Let's now do it for real. This is the kind of thing I think people will use on day 1 when they get to 23 AI. Well, I'll get this demo just done, I think, and then we'll be out of time. So I've got a table here with 330 rows of trivia. Let me give you a sample of rows. So I've got about, I think I got, what have I got? Yeah, 5 different types of data. I've got 60 rows of American cities. I've got 60 rows of car information, 60 rows of fruit, 60 rows of dog information, and 60 rows of cocktails. So as I said, there's random data in there, right? And I'm doing this query. In my trivia table, are there any facts that pertain to cocktails? And this is one of the fundamental problems when it comes to doing ad hoc search in all systems currently. Even though we can see there's some cocktails here, nothing in this table in all 330 rows has the word cocktail in it. There's no understanding of meaning. There's only understanding of text. And this is the killer when it comes to searching in modern applications. I'm creating a directory called models where I'm going to host one of these machine learning models that someone else has built for me. And I'm going to load it. This is the one I downloaded. It's the mini language learning model version 6, version 2. It's Onyx format, this open source format, and is simply loading it into a directory called models. So someone else did all the hard yards in doing a machine learning model to map meaning of text. I'm just grabbing the resultant vectors and loading it into my database as a model. And it's just stored in the data dictionary. Now that I've got that, I can use that model to generate vectors for all that text I had, all those trivia texts. So in this case, I've got 333 rows, and I'm saying, take my document model, take each of the facts, and load them as vectors. My poor little VM here on my laptop is working hard because we're basically creating a 1,000 dimensional array for every single row in this table. Come on, poor little computer. Come on, I'm running out of time. There you go, table created. So if we have a look at it, I've now got my existing facts as before, but every single fact now has got a vector associated with it. I've trimmed it off here, but literally it's literally 1,000 dimensions long. I can also generate the vector for this string cocktail because the vector that comes out of this and its distance from all these vectors defines the similarity in meaning. So there's the full 1,000 dimensions for the vector of cocktail. So I'm going to compare this vector with all the vectors I've generated here. And we do this query here. So I'm going to say, based on the vector distance, how close is cocktail compared to every single one of these trivia facts? Go get the 4 closest ones. And this is what pops out. And as you can see, the word cocktail never appears, but due to this model understands that a cocktail as a vector is similar to a martini as a vector, or a dark and stormy as a vector. It's the closeness of vectors that lets us do this very cool search. I think so. This is the first thing I reckon people will do when they go to 23 AI is, let's give people the search they always wanted. Because everyone always says, why can't I Google my database? This is going to give them that. So similarly, if I look for greyhounds, I get some dog information. If I look for Suzuki, there's no Suzukis in here, but it knows that Suzukis are cars, etc. What if that trivia was all stored in a PDF document? Just a single, this is the exact same 330 rows, but just as a PDF document. Well, the problem, of course, is that's just a single thing. I don't want to actually do a vector for the entire document. I want to go dig into the document and produce vectors for those pieces of text. And I can do this. First of all, I'll load my trivia document into the database. It's 60K in size, so it's a PDF. I can actually do this facility to take my PDF and convert it to text. So this is now still a single piece of text, a single clob with all the text, just one row selected, but we've got facilities to convert it to chunks. I can chunk up that data into multiple pieces of text. Now that I've got it back into little chunks of text again, I can convert it to vectors. And once I've done that, now it's working hard for again, it's converting to every single one of these things as a vector. So if I query it with a bit of JSON, I get, I didn't query the table. Dodgy demo. Anyway, so I'll probably wrap it up there. As I said, if you want to do another session where it's just these remaining demos, be happy to do it. But most importantly, thanks for your time. And simply, if you have any other questions on what was going on today, whatever, ping myself, you can grab me on Twitter, etc. Thanks everybody for your time and hope you enjoyed the session.